Now, next is what are the reactions taking place inside that particular tank. So, first of all, that is cryolite Na3AlF6 will dissociate to give you 3Na plus Al3 plus 6F minus. See, it is very easy to write. 3Na. So, what is the charge of sodium? Plus. Al, how many? 1. What is the charge of aluminium? 3 plus. Total positive charge is 3 and this is 3. 6. Here how many fluoride? 6 fluoride. So 6F minus. So it is, what is the negative charge here? Minus 6. What is the total positive charge here? Plus 6. Plus 6 minus 6. Cancel. 0. It is neutral. Here also you can see it's neutral. This side also total charge is 0. Here also total charge is 0. It is neutral. Alright. In this way we can write it down. No need to mark it up. CaF2 will give you Ca2 plus 2F minus. Here Ca2 plus. Total positive charge is 2. Total negative charge is also 2. That is plus 2 minus 2, 0, again neutral. Alright, now Al2O3 alumina, because 3 are there, na? 3 things are there. Alright, this is one part, this is 3 part, this is one part. So Al2O3 will give you 2Al3 plus 3O2 minus. See, minus 6, it is plus 6, again neutral. Now at cathode, which will go at the cathode. According to the electrochemical series which you have studied in electrolysis, aluminium is lower compared to sodium and calcium. Aluminium is lower in the electrochemical series, and the one which is lower in the electrochemical series, that gets the first preference to get deposited at the respective electrode. That gets the first preference. So aluminium will get the first preference. Al3 plus 3E minus will give you what? Al. See, at the cathode we are getting aluminium. So in the tank we are getting aluminium, on the lining of the tank. Now at anode, which will go, we are having same thing here, oxygen and fluoride we are having. So again oxygen is lower in the electrochemical series. So O2 minus 2E minus will give you O. Alright, O2 minus will lose 2 electrons to form, that is what you can say O. O plus O will give you O2. Now C plus O2 will give you, what is that? CO2, we can say that. C from where it is coming? The carbon electrode, that is your C, we can say that. It reacts. So it may form carbon monoxide also and carbon dioxide gas also. But carbon monoxide is not stable, you know that. It again further reacts with oxygen to form carbon dioxide gas. In this way, carbon monoxide and carbon dioxide gas is being produced, which is being liberated from the anode. So you can see that from carbon where we are getting it. This is the carbon anode, the graphite anode. It is being used. For that reason I said from time to time you have to replace the graphite anode. From time to time you should replace it, the graphite anode. Alright, yes. So in this way you are getting aluminium at the cathode. So aluminium you are collecting it and in the wooden vats. An opening will be there at the bottom. From that opening you collect aluminium in the wooden vats. And this particular aluminium is 99.5% pure. It is almost pure, 99.5%. But if you want, it should be 99.9% pure. Alright, then we have to go for another process. Let's say we have Hoops process. Hoops process. In Hoops process, by Hoops process we can get 99.9% pure. For that reason, what you have to do is that same thing, you have to take a tank. In the tank, first you will put, that is the impure aluminium, which you got it. Just you put the impure aluminium in the tank. Got it? The first layer is the impure aluminium. Then after that, you will be putting a mixture of barium fluoride, aluminium fluoride, and calcium fluoride. You will be putting it. Got it? Which acts as an electrolyte. Understood? Barium fluoride, calcium fluoride, aluminium fluoride. Alright, BaF2, ALF, we can say aluminium fluoride, and CaF2, I should say that. Alright, so in this way you will be putting it, that is a mixture of cryolite also will be adding to it. Clear? Now that will act as an electrolyte, and the upper layer will be the pure aluminium. The upper layer, got it, which serves as the cathode, we can say that. The upper layer, the pure aluminium, which serves as the cathode, and we are having the carbon electrodes which acts as the anode. Just like the previous diagram which you have done it. The only difference is that here you will be taking in layers. So first the lower layer will be your impure aluminium, then the electrolyte, cryolite, aluminium fluoride, barium fluoride, and your calcium fluoride. Then after that the pure aluminium you will be taking it, which acts as a, that is nothing but serves as the cathode, we can say that. So 3 immiscible layers. 3 immiscible. The upper layer is a pure one, lower is the what you can say, the electrolyte, and the middle one is the electrolyte, and the lower is the impure aluminium. Alright, they are immiscible layers, that you must remember it. So in this Hoops process, what you will find is that time to time you will be adding impure aluminium. A pipe will be there which will pass into the tank, and by the help of the pipe you will be time to time you're adding the impure aluminium into the what you can say tank. The pipe will go to the bottom of the tank. Got it? You'll be digging a tank, pipe will be there. By the help of the pipe you will be adding impure aluminium which will go to the bottom of the tank. Alright, because at the bottom only the impure aluminium is being present. Now, what are the electrolytic reduction is going to take place, you can see. So, at cathode, directly we will come to it. At cathode, what you will find is that you will be getting Al3 plus 3E minus will be getting Al. This is your pure aluminium, you will be getting it. The pure aluminium, that is from the middle layer, the aluminium ions is discharged, we can say. From the lower layer, the aluminium ions is discharged, whatever it is, and it goes to the, what you can say, it is being collected at the electrode, that is your cathode, we can say. Clear? Understood? Of course, at the upper layer, pure aluminium is there, no doubt. That acts as a cathode. They are only the pure aluminium from the middle layer, and from the lower layer contains the impure aluminium. It goes and it gets collected at the cathode. So cathode, the layer, it becomes more and more thicker with the pure aluminium. Got it? Because in the impure layer, it's at the bottom. In the middle layer, also we have got aluminium. From where we got aluminium? Cryolite is there. Then your aluminium fluoride is there. Barium fluoride is there. Then that is phosphor is there. Calcium fluoride is there. We have taken it. So from there also, that is aluminium is extracted, and hence aluminium is collected in the upper layer, in the cathode. Now at the anode, what happens? As the anode, I said you, that is itself, it loses, that is what you can say, Al minus 3 minus will give you Al3 plus. Alright, because the impure that is layer which acts as an anode. Of course, we have taken the carbon rods. I said you, we have taken the carbon rods. There is a pure molten aluminium with carbon rods. We have taken it, but actually the lower layer it acts as the anode, because we have connected the battery to the lower layer. Which battery? The positive terminal of the battery to the lower layer, and the negative terminal of the battery we have connected to the upper layer. So hence the upper layer acts as a cathode and the lower layer acts as an anode here. Then you might be thinking, what is the use of taking the that is the carbon here? That is what you can say, the carbon rods. What is the use of taking the carbon rods here? Now this carbon rods, what you find is that when the charge is used up, then the carbon rods acts as a cathode. Alright, it acts as a cathode. Now when the aluminium I have taken it, the pure aluminium I have taken it, so at that time the carbon rod it acts as a cathode, we can say that. Clear? Okay. So that is not required, just for your reasoning I said you, because you may ask me that then why I have taken the carbon rods. For that reason I said. So here the aluminium which you got it is a pure aluminium, 99.9% pure. Because again this from the anode, the impure aluminium, it loses 3 electrons to form Al3 plus. And as I said you already, this Al3 plus it goes to the cathode and it gets collected in the cathode. This is a pure aluminium, it gets collected. In this way you are getting the pure aluminium by the help of Hoops process. This process is called as the Hoops process, it is known as. Where from 99.5% we get 99.9% purity, we can say that. Alright, now if you see the properties of aluminium, it is malleable and ductile, it is a slightly light metal, we can say that. It is highly tensile in nature. That is, it's a good conductor of heat and electricity. Aluminium, definitely, it's a metal. It has got a very high, that is boiling point and the melting point, I said you already. That is, now chemical properties of aluminium, if you see, then aluminium, it is, it reacts with the moisture. It does not have any reaction with the dry air. No, nothing with the dry air, but it gets tarnished in the moisture because it forms alumina, Al2O3. Alright, alumina, we can say that. On heating in air, it burns with a bright light. Alright, note it. On heating in air, it burns with a bright light, forming aluminium oxide and aluminium nitride. We can say that. Aluminium oxide and aluminium nitride it forms. And that is Al plus O2 will give you Al2O3, aluminium oxide. Al plus N2 will give you Aln, that is aluminium nitride, so to say. But it is unaffected by distilled water, pure water. Pure water has got nothing, no effect upon it, but definitely the water, that is your steam or the hot water, definitely it reacts with it. It reacts to give alumina, Al2O3. That already we have studied. That is aluminium, we will be passing steam through aluminium, That is, of course, it should be heated aluminium. Alright, then what you will find is that it forms Al2O3 and hydrogen gas is released. Already I have discussed with you in the beginning of the chapter. Alright, now aluminium reacts with chlorine to form AlCl3. It also reacts with sulfur to form Al2S3, aluminium sulfide, and the reaction is highly exothermic in nature. It's highly exothermic in nature, heat is liberated. It reacts with acids as well as with bases. Already I have said you, because aluminium is amphoteric. So aluminium reacts with acids, that is Al plus HCl to form AlCl3 and hydrogen gas is liberated. It also reacts with the base. Aluminium plus sodium hydroxide will give you NaAlO2 plus hydrogen gas is liberated. Again I repeat, aluminium reacts with sodium hydroxide, Al plus NaOH will give you NaAlO2 and hydrogen gas is liberated. It also reacts with acid, Al plus HCl. Al plus HCl will give you AlCl3 and hydrogen gas is liberated. You can balance this equation, you can write it and balance it. Alright, similarly it reacts with other acids also, like sulfuric acid, it reacts to give you same thing, salt and hydrogen gases being liberated. But if you take concentrated sulfuric acid, then what you will find is that sulfur dioxide is also being liberated along with water. If you take concentrated acid, that is Al plus H2SO4 concentrated, you will be getting Al2SO4 whole thrice plus water plus SO2 if you take concentrated. But if you take a dilute here, you will be getting Al2SO4 whole 3 plus hydrogen gas is liberated, we know that. Now with the dilute or concentrated nitric acid, aluminium is rendered passive. Why? Because an insoluble layer settles over the surface of aluminium, that is Al2O3. An insoluble layer, because here nitric acid acts as an oxidizing agent. It acts as an oxidizing agent. It converts aluminium to alumina, Al2O3. And that Al2O3 is an insoluble layer. It settles over the surface of aluminium and it prevents further reaction. It prevents further reaction. That is called as passivity or inertness. So hence, when aluminium Al reacts with the dilute nitric acid or concentrated nitric acid, aluminium becomes passive. Means further reaction is being prevented. It does not react. As I said you, because a layer, an insoluble layer settles over the surface of aluminium which prevents further reaction. It also acts as a reducing agent. Alright, that is, we can say that aluminium. So, if you take the metallic oxide below aluminium, it reduces. So, that is Fe is there, let us say. So, aluminium plus ferric oxide will give you nothing but Al2O3 plus Fe. You can see ferric oxide loses oxygen and it forms, that is iron, we can say that. So Fe2 means 2, that is, we can say that, and here it will be 2Al. Clear? So in this way, this is an exothermic reaction. So it reduces iron, it reduces chromium, it reduces manganese, we can say that, because these metals are below aluminium in the metal activity series. So these are the properties of aluminium. Now aluminium, it is used for making of what you can say, utensils. Aluminium, it is used in the making of what you can say, that is paint. Aluminium powder plus linseed oil, it is used for the making of paints, which is used to paint the iron poles, we can say that is aluminium layer actually prevents corrosion. The metal does not get corroded, the iron poles does not get corroded, so hence it is mixed with paint in linseed oil and it is used to make paints. Got it? That is aluminium that is used for packaging purposes. The aluminium foil, thin foil of aluminium is used for packaging of food materials, we can say that, packaging of articles. It is used, aluminium, it is also used for electrical cables, you can say the aluminium wires, the overhead wires. Got it? It is used for making of alloys like duralumin, magnesium. These are the alloys it is used because aluminium is quite light metal. It is quite tensile in nature and is corrosion resistant. It does not corrode easily. And the most importantly, aluminium is used for thermite welding because the bridges and the girders, got it, when it breaks, got it. So suppose the bridge is there and it breaks here, got it, a crack develops here. So how will you fill up the crack? You will be going for thermite welding, that is aluminium and ferric oxide, a mixture is taken and it is being welded. And why aluminium is taken? Because you have seen that aluminium reduces ferric oxide to alumina and Fe. Now this Fe, it fills the cracks, we can say that. Aluminium oxide, it fills the cracks. Got it? And aluminium is a corrosion resistance, it does not corrode easily. or it does not corrode easily, and this sort of welding is said to be as thermite welding, so to say. And I said you that why it is used, because aluminium is used as a strong reducing agent. For in thermite welding we are using aluminium. Yes, so thermite welding, where it is being done to what you can say, repair the bridges and the girders, we can say that. So these are the properties and the uses of aluminium, so to say. Thank you.